In the next two lessons, we're going to look at electromagnetic waves. Now, before we discuss these in detail, there are one or two general statements that we need to make. First of all electromagnetic waves are transverse waves. That's to say, they vibrate in a perpendicular direction to the direction of propagation. Secondly, that all electromagnetic waves travel at the same speed. Okay, so in a vacuum, let's just say in free space, they travel at the speed of light. That's c, which is equal to 300,000 kilometers per second. So let's look at the family of EM waves. So right in the middle here we have the visible spectrum. We've got Richard of York gave battles in vain. Right, so that's visible light. This is the region of the EM spectrum which is visible to our eyes. The cells on our retina respond to this part of the electromagnetic spectrum. So at this end we have radio waves. We'll talk about those more in a minute. Then after that we have microwaves, then infrared, and then after visible we've got ultraviolet, then X-rays, and then finally gamma rays. So we've divided that up into a family of 7. And as you move from this end of the spectrum, from radio through to gamma rays, you'll notice that the wavelength decreases, and because the speed of the waves is constant, irrespective of whether they're radio or gamma, then we can write V equals lambda times the frequency. So therefore, if the wavelength is decreasing as we move that way, then the frequency must increase. Alright, so as we move from radio to gamma, the frequency of the radiation increases. Now, as we'll see in a minute, electromagnetic waves are very important in the area of communications and telecommunications. And what basically is important in communications is how much information you can carry using a particular type of EM wave. So we can say that as we move, as the frequency of the wave increases, the amount of information that it can carry increases as we move this way. So in this part we're going to look at radio, microwave, infrared and visible, and then in the next part we'll look at ultraviolet, X-rays and gamma rays. We're going to look at their uses and also have a look at their dangers. First of all, let's start with radio waves. So radio waves can be divided into 4 types. Let's do that. We've got long wave, medium wave, short wave, and then what we call VHF. That's very high frequency radio waves, which is used to transmit, for example, TV signals and FM radio, for example. Okay, so let's have a closer look at these. Now, the long wave radio can be anything from 10 kilometers to a kilometer. Then medium wave from a kilometer to 100 meters. And then short wave from 100 meters to 10 meters. And then finally VHF from 10 meters to 10 centimeters. Okay, so first of all, let's just think about the long wave radio. What's the advantage of that? Well, mainly in the way that it's transmitted. Because it's long wave, then the wavelength is similar in distance to the size of large objects such as mountain ranges or tall buildings. This means that long wave radio waves are diffracted, that's bent around objects and through gaps. So for example, in this case we've got a long wave radio transmitter and we've got a house the other side of the mountain. Well, because the long wave is diffracted around the mountain, the house can receive the signal. So this diffraction effect occurs with both medium and long wave radio transmissions. Now the problem with long and medium wave is that although they have large wavelengths, they have low frequencies, and that means they're not able to transmit large amounts of information. So it's okay if you've got a radio here and all you've got to transmit is audio information. When you want to start transmitting more information, for example in the case of television, where you have to include not just audio information but visual information and information about colour, and then we need to go to higher frequency radio waves such as shortwave or VHF. Now the problem with shortwave or VHF is now that they have very small wavelengths, okay, like this. So what that means is they will get blocked by the mountain here, and there will, although there may be a little bit of diffraction of the waves, the shortwave or VHF radio transmissions aren't going to reach this house. They're going to be blocked by the mountain. So in order to overcome this, what we're going to do is we're going to send the radio waves up into the upper atmosphere, where they will be bounced off of a layer called the ionosphere. And the ionosphere is a layer of charged particles which reflects radio waves. So we send the signal up to this layer and it's bounced off again, and so forth. So the signal is transmitted in this way.